Evening all. There's the notion that geometry has a relationship to sound. The interior angles of a triangle add up to 180 degrees, and perhaps that corresponds to 180 vibrations a second. It's an interesting idea, and let's explore it a little bit. So triangle is 180 degrees. A square is 360 degrees. There's 4 90-degree angles. And a circle is 360 degrees. A hexagon is 720 degrees, which is double 360, which is double 180. So these are octaves of each other. A tetrahedron, four-sided solid, all the sides are triangles, is also 720 degrees. And a decagon, 10-sided figure, and an octahedron, these are 1440, again, double this. So these are all of a sort of an octave notion. But I would say these are not what you usually are told, that this is an F sharp, at 360 vibrations a second. Because when degrees were worked out by the ancient Hebrews as being the way to divide the rotation of the earth, they did not have seconds. They had heleks, and a helek is 1/72nd of a degree of rotation of the earth. So if there is a correspondence between geometry, which is the measure of the earth, and music, it's going to be vibrations per helek, more likely, than vibrations per second. So if we do that mathematics, if we convert any of these numbers, divide by 3.333, you're going to get an octave of A at 432 hertz. So not an F sharp, but an A. Similarly, the next band of shapes, pentagon, octagon, 540, 1080 degrees, and a cube, the interior angles add up to 2160, which is double that, which is double that. So these are octaves. But again, this is not a C sharp. When we divide this into vibrations per helek, ancient Hebrew helek of 3.333 of today's seconds, you get an E of 324 vibrations a second, which is the third harmonic of that A. So we've got an A and an E. The next band of geometric shapes, the 7-sided figure and the 12-sided figure, septagon and dodecagon, I think, 900, 1800, those are double each other, and icosahedron, I don't know how many sides that's got, but anyway, it's 3600 degrees. Those are all octaves. That's not a B flat. If you divide that by 3.333, that actually is a C sharp. So there is a C sharp in it, and that's the 5th harmonic of the 432. So you got a root for A, you got the 3rd harmonic of it, an E, and the 5th harmonic of that A, the C sharp. This gives you an A major chord. And then the final figure is the dodecahedron, which comes to 6480 degrees, which is not an A flat. If we divide that by 333 to bring it into seconds, it's a B of 486 vibrations a second. So let's hear what those sound like. So the normal way of thinking is you've got your 360 degree vibrations a second, 540, 900, 6480. And I'm here to say that I think it's 432, 324, 270, and 486. And if I was a geometric shape, I would think I would want to sound more like this than the other ones. So there you go. Thank you.